Number 26. The following nuclei do not lie in the band of stability. How would they be expected to decay? And then we have to explain our answer. Okay. So, if these, or this specific nuclei, does not lie in the band of stability, that means that this is an unstable and a radioactive material. So, the question is, how is this nuclide going to become stable again, right? How is it going to decay? Now, there's many different types of decay modes, whether we're talking about beta emission, so releasing an electron, positron emission, releasing a positron into the atmosphere, alpha emission, releasing that alpha particle or a helium, or taking up an electron. Now, the main thing to rule out is look at the atomic number first, right? Anytime that you have an atomic number that's greater than 83, chances are this is going to be undergoing alpha emission. But we have an atomic number here. I mean, it's hydrogen. I only have an atomic number of 1. The atomic number is always the lower number of the two numbers on the notation. So I know now I have to deal with these NP ratios. Now, if we wanted to actually find out the ratio, we would have to find out the total number of neutrons, that's what the N stands for, and the total number of protons, and divide them, right, to get the actual ratio, and see whether the ratio is either a high ratio or a low. But there's an even easier method, which I will tell you right here. High N to P ratios always correlate with a high atomic, we'll say a high mass number, right? And the mass number is the number of protons and neutrons. If you have a high ratio, you have a higher amount of, the mass number. On the flip side, if you have a low N to P ratio, you're going to have a lower mass number. So it's easier to not find out the total number of neutrons and protons, but just look at the mass number. But the question here is when I do look at my mass number, which is the higher number out of the two numbers that are given in your notation, right? This is the mass number. And you could also say, atomic mass, it doesn't really matter to me. But is this 3 a high or a low value? What's going on? Well, enter in the best piece of paper ever in the chemistry course, the periodic table. Now, on the periodic table, they give you basically the average atomic masses, right? And for the periodic table for the hydrogen, they're going to give you the average, which means that they take all of the nucleides on Earth, right, crunch them all together, and they give you out an average value. But the average atomic mass that's on the periodic table for my periodic table is 1.008. Now, always round this value to the nearest whole number. This 1.008 is roughly around 1. That means that hydrogen wants to have a 1 as its mass number. This is the stable form for hydrogen. But in our example, we have a 3. This is a way too high mass number. So all you're doing is you're just comparing what the mass number that they gave you is to the general whole number mass number on the periodic table. Since now we have a way too high mass number, we know that we got to bring that ratio down. And the only way to do that is by beta emission. So by releasing an electron into the atmosphere, you will bring down that N to P ratio. And explain your answer. It's basically everything that we just went over about talking about the ratios, mass numbers. So you got this. What'd you think? Hopefully this helped. Let me know in the comments. Thank you so much for viewing the video. I hope you're having a lovely day out there. I hope you're having a lovely day out there. Keep studying hard. I'm always rooting for you guys on your tests and quizzes. And I love hearing back when you guys, let us know what's going on in your class. So thank you so much for all your support. And we got memberships on the channel if you want to become a member to the channel. Not obligated though, but thank you for considering. And I'll talk to you soon, okay? All right, bye-bye.